Okay, today is the day we apply the law of cosines as well as the law of sines. I would say law of cosines is probably more applicable. Students often ask, when are we going to use this in mathematics, or when are we going to use this in real life? I give you real life examples. Unfortunately, sometimes is the time that people shut down and say, well, I'm not so sure that I'm interested in doing that. Hopefully we can figure it out. Two ships leave a port at noon. Ship A is traveling at a bearing of north 32 degrees west at a speed of 5 miles an hour. Ship B is traveling at a bearing of south 75 degrees east at a speed of 4 miles an hour. How far apart are they at 4 p.m.? Where do you want to start? Draw it, make a picture, sounds like a good idea. So I'm going to say that they start at P for port. Draw a grid. So I see bearings here. I need to try to get kind of a compass idea of what's happening. So ship A travels at a bearing of north 32 degrees west. So should I go to the right or the left? Tell me when to stop. Okay, thank you. Yep, good word. Stop. Thanks. All right. And travels at that bearing, stops after, or you know what, this is point at where it is right now, so we'll call it point A. Okay, then we get another one traveling south 75 degrees east. So we'll start south. Yep. Just tell me. Yep. Okay, yeah, that's reasonable. Remember that this angle right here should be 32 degrees. And this angle right here should be 75 degrees. That's your turn from north or from south. So the question is, how far apart are they at a certain time? Well, right now I don't have any lengths. I simply have a drawing to represent the angles. Can somebody give me some distances? What time do they leave? Noon. What time is it now? How many hours have they been traveling? What's their rate? So what's the distance? 16 and? So, yep. So that'll be 16 miles for ship B. How about ship A? 20. Okay, I've got two sides. I need an angle. Find that angle. Oh. 32 plus 90 plus 15. Yep. This is 75, and that little bit's going to be 15. So 132, or 122 plus 15 is 137. And I want to know this side right over here. Which of the 6 triangle scenarios do you have in play right now? If you frown, your face will just stay that way. It's exciting. We have a wonderful opportunity. We can look at which 6 triangles it satisfies. It does satisfy side, angle, side. Which do we use? Law of sines or law of cosines? Law of cosines. We want to find the opposite side of the angle. So c squared is equal to a squared plus b squared minus 2ab times the cosine of c. You could pick D and put D there. I just chose to say this is the side opposite these two spots. I'll call A the distance that A has traveled. How far has A traveled? 20. As far as B traveled, 2 times 20 times 16 times the cosine of 137. This is easy now because we all know how to solve the law of cosines and use it. 20 squared, 16 squared. That's 2 times 20 times 16 times cosine 137. And I will square root the answer, 33.53. Again, if you're wondering application of trigonometry, there's a clear example. Question. Okay. So we're traveling at a speed of 5 miles an hour, and we're traveling at a speed of 4 miles an hour. We left at noon, and it's 4 p.m. So my total time of travel is equal to 4 hours, and my rates are equal to 5, 4. I'll just multiply those two together. Because distance is equal to my rate times my time. Distance is rate times time. Okay, we try a different one. Plane flies at 300 miles at a bearing of north, 80 degrees east. Plane turns and flies 400 miles at a bearing of north, 20 degrees east. How far is the plane from its original position? That's what we're trying now. Draw our picture. Say that that's the airport. North 80 degrees east. You tell me when I'm at north 80 degrees east. Okay. So at some point, the plane turns north. After how many miles does it turn towards the north? 300 miles, it then turns towards the north. Yep, I did. So now, it turns not straight north, but at north 20 degrees east. Tell me when I'm at north 20 degrees east. Okay. And how far is it flown in that direction? 400 miles. The question is, how far is it from its original position? Yep, I just continued the bearing on to try to give you guys a hint. So I really don't want to tell you this next part, but I'm afraid you won't be able to figure it out. Not a right triangle, can't use Pythagorean theorem. You think it's 120 on the inside. Why? Very good. So, Kelsey said that it's traveling at an 80-degree bearing, and then it turns to a 20-degree bearing. That means it turned 60 degrees. Kelsey, YouTube Nation needs to hear that. Okay, they don't know who you are. This is Kelsey. Kelsey, can you please tell YouTube what you just said?
Finally, I did something right.
Okay, all right. There's nothing wrong with putting forth an answer that's not correct. We keep trying. We show persistence. Way to show the star quality of perseverance. Nice job. All right. For Kelsey, 1, 2, 3. Whoa. 2 claps. For Kelsey, 1, 2, 3. All right. Just making up stuff now. All right. So, Kelsey, what is then this angle right here? 120. So I tried to give you a little bit of a hint by drawing that bearing a little bit further so you could see this angle, and that's kind of what happens. So now, what kind of triangle do I have? Side angle side, which requires the law of cosines. And so I'm not going to use the letters A, B, and C. I'm just going to write it out generically. I chose this to represent distance. So distance squared is equal to one side squared plus the other side squared minus 2 times the product of both sides times the cosine of the included angle. So hopefully after a while you don't really need the letters for law of sines and law of cosines, but rather you can think through conceptually what's happening. Take out my handy dandy calculator. By the way, Tanner is watching these videos. He emailed me this morning. Tanner, they miss you. He emailed me and told me that he misses you guys. So he did start naming people, but I won't go into that. Not Ryan, Tanner. Tanner, we are hoping that the seagulls are doing well, and we hope that you bring us something back, like sand, or a sun, or something. So, is that my answer? Squirt the answer. I get 608. Okay, in example 3. This is what we'll get through today, and then on tomorrow, um, we'll finish stuff up, and you'll have a little bit of time to ask some questions. I really, really want you guys to try to help me out with this problem right here. Try to help me out with the drawing. It says point A is due north of point B, and point C lies to the west of both. What? Draw a vertical line. Okay. Got it. Now what? Put A and B. Yep. You don't want to hear? You want to hear? It just says it lies to the west of both. So it. All right. Okay. Hi, Kayla. All right. The question is, and I apologize, I will not word those like that. I'll say B2C and A2C. Okay? I'll phrase it like that. So I want to know a bearing. Well, in order to know a bearing, I should really figure out angle B and angle A, correct? tell me. What do I use? Which requires the law of cosines. Which angle should I solve for? The biggest one, b. Very good. So b squared, a squared plus c squared minus 2ac times the cosine of angle b. Yep. Yep. In order to compute this, I have to subtract those pieces over. So I have 225 minus 169 minus 144. I get negative 88. I'll take negative 2 times 13 times 12. I get negative 312. Cosine inverse the answer, 73.62. If you want to know the bearing of B to C, what direction is it from B to C? North, west. How many degrees to the west of north? Good. In order to do A to C, I'm going to have to know this angle, right? I have to figure out that angle. Law of sines. Sine is 73.62 over 13 equals the sine of A over, whoop, did the exact same thing. Inverse the answer, 56.25. So, what's the direction get from A to C? Southwest. How many degrees to the west of south? Good. If you wanted to convert these to standard form, could you? Just either add 180 or subtract 180 or 360, however you want to do it. Um, you should be able, on the test, you guys, I'll just ask for one or the other. As long as you can do one, it's fine by me. For your worksheet, I want you to list both. On the test, you just list one. Okay, we'll pause there. We'll have to finish up the notes tomorrow. There's no new assignment today. You'll get the new assignment tomorrow. Do you have the study guide? I will give you the study guide. But if you don't want it, I just give it to you tomorrow.